Okay, suppose ARB grants your firm a license to directly sell electricity to consumers, as indicated by an estimated residential demand function for electricity. This is your demand function, where the amount of electricity consumed sells for 0.44 per unit, good Y sells for 1 kwacha per unit, and the company utilizes 2,000 units of advertising in public information campaigns and consumer education regarding electricity. And consumer income is 10,000 kwacha. Part A. How much electricity should each consumer purchase? So here, colleagues, just know anytime you see this type of demand function, no matter what the question is, just know whatever values you are given in the question, you have to put in the demand function. Okay, so this is the demand function for good X. Good X is electricity. So anything that has an X attached to it is dealing with the good X. So this PX is the price of good X, the price for our electricity, which is this 0.44. This AX here represents the advertising for electricity good X, which is 2,000 units. Okay. Good Y sells for 1 kwacha per unit, so PY here. Consumers income 10,000 here. So how you interpret this demand function? The demand for electricity is dependent on 4 factors. It's dependent on the price of electricity. It's dependent on the price of good Y. It's dependent also on the income and also the amount of advertising. These 4 factors affect demand. How to know how they affect demand? Just look at the signs in front of each of these variables. Okay. If we look at the relationship between the quantity demanded and negative 3px, or the price of the good, because of this minus sign, it tells us the law of demand, which says there's an inverse relationship between the price of a good and the quantity demanded of the good, ceteris paribus, meaning holding these 3 other factors constant. If we look at quantity demanded and the price of the good X, and if we hold the other factors constant, there is a negative relationship. Meaning if price goes up, it means quantity demanded goes down because of this minus sign here, showing the law of demand. If we look at the relationship between the quantity demanded of good X and the price of good Y, we can see a positive sign here, meaning there's a positive relationship. If you hold other factors constant, there's a positive relationship between the price of good Y and the quantity demanded of good X. If you increase the price of good Y, it means it becomes more expensive, and people will now substitute good Y with good X. Therefore, quantity demanded of good X will rise. Okay, so here I've already answered part 2 of the question here. Electricity and good Y are substitutes. Why? Because of this positive coefficient. Okay, this positive coefficient. Okay. Due to the positive coefficient, it tells us there's a positive relationship between the price of good Y and electricity. If the price of good Y goes up, People substitute good Y with good X electricity, and therefore the quantity demanded of good X of electricity goes up. Then, if for example there was a minus sign, if PY had a minus sign, okay, if in the exam you see PY has a minus sign, then know the goods are complements. Okay, if you see maybe a minus 2PY, just know that, okay, because of this minus sign, good X and good Y are complements. Okay, meaning if the price of good Y goes up, since it's used in conjunction with good X, so it means people stop buying good Y. And if they stop buying good Y, they'll stop buying good X, meaning quantity demanded of good X would go down. Okay, so if the price of the other good has a minus sign, complementary goods. If the price of the other good has a positive sign, substitute goods. Are we clear on that? Any questions? Because there are many ways these demand functions can come. So when you look at PY, or maybe if it's another letter used, just look at what letter is used on the quantity demanded. Okay. So if you see the price of another good has a minus sign, they are complementary goods. You see the price of the other good has a positive sign, substitute goods. Then if we look at the relationship between M and good X, okay, there is a minus sign here. Okay, if we hold all other factors constant, Px, Py, and A, we hold them constant, and we look at the relationship between M and QDX, there's a negative relationship. Because of this minus sign, it means if people's income goes up, they stop buying good X. They start buying another good. Okay, so quantity demanded goes down. Okay, so this tells us we're dealing with an inferior good. So we've answered part 3 there. Here we're dealing with an inferior good. Meaning, inferior goods, when your income increases, you buy less of them. Okay? Think of, let's say, someone who drinks shake shake. If the income increases, they'll stop buying shake shake and they'll start buying other things like Mossy, Castle, okay, to improve their levels. Okay. If their income goes down, it means they'll have to revert back to the shake shake. Okay, so meaning quantity demanded of shake shake. If income rises, quantity demanded of shake shake will go down. When income drops, quantity of shake shake is going to increase. Okay. So when you look at income, whenever you see an M in a demand function, if you have a negative sign, you're dealing with inferior goods. Meaning if your income goes up, you buy less of that good. If your income goes down, you buy more of the good. Inverse relationship. If we had a plus sign in front of the M, then we're dealing with a normal good. Meaning if your income increases, you buy more of the good. So even quantity demanded would go up. Positive relationship. If your income reduces, you buy less of the good. Okay. Normal goods, there are many examples. Okay. Tea, bread, okay, potatoes, chicken. Your income increases, you buy more chicken. Your income drops, you buy less chicken. So I hope you've remembered. For substitutes and complements, you look at the sign negative, complementary, positive, substitute. For normal and inferior goods, negative sign, inferior, positive sign, normal good. Okay. Then this part here, which says how much electricity should they purchase, you just as I said, you substitute the values into the equation. Q equals 12,000 minus 3. Px, you substitute with 0.44 plus 4py, substitute it with 1 kwacha, minus m, which is 10,000 kwacha, plus 2a, advertising 2,000. Can someone calculate that for me? Can somebody calculate that for me? Give me the value of this. Give me the value. What value are we getting? What value are we getting? Uh-huh. Let's see, is it a message or is it... No, not negative. non-negative. Just try it again. Has anyone given another value? Has anyone found another value? Mm-hmm. Are we all getting this value? Are we all getting that value? If you are not, you can tell me what value you are getting. Just see, you have confirmed 6,002.68. Now, you might also meet questions on elasticities of demand. Okay, they might ask you find the own elasticity of demand, the cross price elasticity of demand, and the income elasticity of demand. So I'm going to show you how to get the price elasticity of demand. Then you try to, then I'll let you try to get the cross price and the income elasticity of demand to practice any partial differentiation that can come your way. Okay. So if in this question here, if they ask us find the own price elasticity of demand, you're told find the price elasticity of demand, how quantity demanded responds to changes in price. That's what elasticity of demand is. How quantity demanded responds to changes in price. Okay. So if there are questions if they brought any question on elasticity of demand, first things first, you need to get this Q, the 6,002.68. Then to get the price elasticity of demand is the partial derivative of the demand function over the partial derivative over, oh, wait, they are deriving it with respect to px. That's what I mean. Okay, you're partially deriving the demand function with respect to px. Okay, then you multiply that by px, price of good x, over q. Okay, that's what you need to do. Okay, this is the formula for price elasticity of demand. Okay, so what it means, our demand function, we're going to derive it with respect to p, meaning any number that doesn't have a px, since we're deriving it with respect to px, any number that doesn't have a px is disappearing. So colleagues, pay attention so that the next one you try, so that should you see such a question, you will be able to attempt. So if we're deriving with respect to px, this 12,000 goes. This 12,000 represents the quantity demanded if the price of good X is 0, price of good Y is 0, income is 0, and advertising is 0. And the quantity demanded would just be 12,000 units. So it disappears. This 4PY goes. This M goes. This 2AX goes because they don't have a PX. So it means we're just deriving negative 3PX. So just the same way you derive 3x like this, when you derive 3x, you get your answer as 3. It's the same way here. The only difference is x is px here. So if we derive with respect to px, our answer is negative 3. Any questions? Okay, then you get the absolute value. Meaning you ignore the negative sign. This is because the law of demand, due to the law of demand, px is always going to have a negative coefficient. And whenever you are determining if demand is elastic or inelastic, you have to compare it against the number 1. Okay. Anything below 1 is inelastic. So if every time you calculate a negative value, it means all the time your demand is inelastic. So that's inaccurate. Okay. That's why we ignore the negative sign by getting the absolute value so that we can evaluate our price elasticity of demand if it's less than 1 or greater than 1. Because if it's negative all the time, it's always going to be less than 1. And you just be reading as inelastic. So you get 3. Then we come back to our formula here. So we substitute this with 3. Price of good X, 0.44. Over quantity demanded was 6,002.68. Someone with a calculator, 0.44 divided by 6,002.68. 0.44 divided by 6,002.68. Mm-hmm. Anybody? 0.44 divided by 6002.68. It can't be 7.33. The number has to be low. 0.44 divided by 6002.68. Or is your calculator saying 7.33 to the e to the power negative 5? Mhm. So now, in decimal form, how will you read that number? Since it's e to the power negative 5, it just means there are five zeros before 7. Because you might encounter these values. Okay. Then we multiply it by 3, we get 0.0000219. So since this value we've calculated, price elasticity of demand, it's less than 1, because you always compare your answer against 1. Since it's less than 1, so we say demand for electricity is inelastic, meaning it's not sensitive. It's not very sensitive to changes in price. It's less, it responds less, okay? But it's not sensitive to changes in price, okay? Meaning price can even increase by, let's say, 50%. You just see quantity demanded maybe drop by maybe 10%. Okay, it's not very sensitive to price changes. If our value was greater than 1, where demand is elastic, it means quantity demanded is sensitive or responsive to changes in price. Okay, meaning, for example, if demand was elastic and price increases by 50%, you find quantity demanded will drop by 100% because it's responsive, it's sensitive. So even a small change in price will have a big effect on demand. But when demand is inelastic, even a big change in price will have a small effect on demand. Are we clear with that, colleagues? Because price elasticities are coming. One way or another, they will come. So you must know how to interpret and what the meaning of each is. Any questions? If they ask you to get the cross price elasticity of demand, it means how the quantity demanded of one good is affected by the price of another good. Okay, so here it will be where you're comparing PX, how quantity demanded of Px responds to changes in price of Py. Okay, that's cross price elasticity of demand. Okay, how the quantity demanded of one good is affected by the price change of another good. Okay, so cross price elasticity of demand, XCD, they have to ask you to calculate that, is the partial derivative of the demand function with respect to Py multiplied by Py over Q. So colleagues, to make sure you've understood this partial differentiation, here's the demand function. Derive it with respect to Py, meaning if a number hasn't got a Py, it disappears. So if we derive, what value will we get? That's for Py minus. Look at how we derived for x and apply the same principle here for y. Anybody to give it a try? Just remember, where the number doesn't have a Py, it disappears. Has anyone derived? Look at this example here. When we're deriving with respect to Px, now apply it here when you're deriving with respect to Py. Yes, Mr. Himonde. What value are you getting? And let's see who else is on the call. What value are we getting? Mr. Manasseh? No one has found a value. Okay, then the other one is income elasticity of demand. How quantity demanded of one good responds to changes in the price of the good. The income of the good. Okay, how quantity demanded of one good responds to changes in income of another good. This is the one which determines inferior and normal goods. Cross price elasticity, it determines substitutes and complementary goods. If your cross price elasticity is positive, substitute. Your cross price elasticity is negative, complementary good. Complementary. So income elasticity of demand, positive, normal good. Negative, complementary good. Okay. So even with this one, you're just deriving your demand function with respect to M. Okay. But partial derivative of Q dx with respect to M multiplied by M over Q. Okay. So your homework for tonight, you derive this one with respect to Py. Then also you derive this same demand function with respect to M. Okay. Then you'll be able to tell if you, and then here just substitute Py with the price given, which was 1/4. Q will always stay the same, 6,002.68. Even here, Q 6,002.8. M here is going to be, is it 10,000? Yes. Then you just multiply and just see your values if they are, and you'll be able to determine if they're substitutes or complementary goods.